Mind-blowing how the internet travels across ocean. Just a post button is all it takes for something to start chatter in another part of the world. Technology truly has no barriers. Nowadays, people think having the internet is more important than having a stable home. Hey everyone, and welcome back to our Incredible Tech. Today, we will talk about how the internet travels across the ocean. So make sure to stay until the end of the video, subscribe to our channel, and ring the notification bell to keep updated with all our videos. To support our insatiable demand for communication and entertainment, nearly 750,000 miles of cable already connect the continents. Companies have typically pooled their resources to collaborate on undersea cable projects, similar to constructing a freeway for everyone to use. While most of us now access the internet through Wi-Fi and phone data plans, those systems eventually connect with physical cables that quickly transport data across continents or oceans. The cables begin as a tangle of strands of tiny glass fiber threads. Using fiber optic technology, lasers propel data down the threads at nearly the speed of light. After landing and connecting to an existing network, the data required to read an email or open a web page is transferred to a person's device. According to the authoritative Submarine Cable Map website, 493 operational or actively in construction subsea internet cables are crossing the globe as we delve into the depths and wonder how the internet gets across seas. These span many lengths, from the undersea Maria cable connecting Virginia Beach in the United States to the enormous 6,600-kilometer Azerbaijan to Turkmenistan wire. Maria reportedly weighs the same as 24 blue whales with a bilbo in northern Spain. There are currently 5.5 million kilometers of subsea data wires, thanks to the company's global installation of this serpentine superhighway. What is the whole cost? A typical transoceanic cable is expected to cost between $300 and $400 million, which seems expensive given that they are typically only about the thickness of a garden hose and contain protective thixotropic jelly around the crucial fiber optic core, as well as numerous plastic sheaths and copper wiring for power. The question of how so much data can fit along such narrow channels is raised even though they can, on average, transmit an amazing 100 gigabytes of data per second, with newer and upcoming cables capable of transmitting 400 gigabytes per second. Dense wavelength division multiplexing, a highly complex data wrangling method, contributes to the solution. Low-density wavelength division data providers can transmit information fiber optically by multiplexing such that more than one wavelength of light can be used. Instead, numerous wavelengths are used simultaneously and layered to produce incredible data speeds. This occurs at landing sites that hum like data centers at the cable's ends or along the straight of the cables. There are supposedly repeaters spaced roughly every 70 to 100 kilometers along the long wires that make up the seabed channels. These essentially act as amplifiers to maintain the signal's quality over great distances, so the cables feature copper conductors that can carry up to 10,000 volts of direct current to power the repeaters. What are the cables made of? The cables are manufactured in high-speed mills the size of jet engines, which wrap the wire in a copper casing that carries electricity across the line to keep the data moving. Plastic, steel, and tar are added later, depending on where the cable will be installed, to help it withstand the unpredictable ocean environments. The cables will be the size of a thick garden hose when finished. These cables primarily use fiber optics to transmit light messages, with lasers that fire incredibly quickly from one end. The actual glass fibers that achieve this are tiny. Their width is comparable to that of human hair, but many layers protect them. In shallower places, there is a higher likelihood of coming into touch with ships and other objects. Hence, the layers of protection are strengthened. They are also buried near the shore of an additional defense measure. In contrast, a special machine is used to lay the cables straight on the ocean floor in the deep-sea regions. How are the cables laid? On specialist cable-laying ships, they are initially wound into enormous cylindrical drums. The planning and mapping for this process can take up to a year. The ideal transoceanic route should avoid volcanic areas, particularly prone to earthquakes or mudslides, or areas where fishermen constantly fish. If the ship encounters heavy weather, the captain can choose to cut the line, tie it to a buoy, and retreat to calmer seas until the storm passes. Workers inside the ship spool the cable into massive tanks. One person walks the cable in a circle as if laying out a massive garden hose. while others lie down to keep it in place and prevent it from snagging or knotting. Even with teams working around the clock, it takes about 4 weeks to load the ship with enough cable to set sail. When it returns, the ship picks up where it left off with the buoy. On the cables, mishaps and outages can and do happen. In 2011, the Fukushima earthquake in Japan had a similar effect on line as Hurricane Sandy in the United States, taking out numerous important transatlantic cables and causing networks to go down for hours. The majority of these disturbances, however, are caused by human negligence. Often, trawler nets or errant ships are at risk, as are anchor lines that lie close to the coast. Therefore, it is more likely that it will be carefully armor-plated closer to the lander cable. Many are even buried into the seabed in lengthy dedicated trenches scooped out by ship-drawn plows. Amazingly, one of Google's undersea cables has been discovered to be being nibbled on by sharks. Even more sinister, the US government has repeatedly warned of foreign adversaries like Russia or China interfering with the cables. The US government ought to be fully aware of the revelations made by whistleblower Edward Snowden in 2013 regarding the NSA's willingness to eavesdrop on fiber optic communications. Undersea cable ramifications for geopolitics are also fascinating this year. The Solomon Islands and Australia would have been connected via cable, but the Australian government stepped in to stop the installation. There is concern that China would exploit the link to infiltrate Australia's private internal networks. The topic of who truly owns these wires is intriguing. It's a costly business, so historically nations or quasi-national telecom companies have footed the price. With a share in almost 230,000 kilometers of undersea cable, America's AT continues to be the largest cable owner in the world. China Telecommunication is the second largest owner. When something goes wrong and no one can agree on who should put on a wetsuit and fix it, cables are frequently owned by groups or consortia of up to 50 owners, including tech companies, local government agencies, and other businesses. While this model helps spread the initial cost, it is less helpful when something goes wrong. More and more significant tech companies realize that the underwater cable network restricts their ability to expand. Therefore, during the past few years, firms like Facebook, which presently controls approximately 100,000 kilometers of cables, have made the vast bulk of investments in underwater cable infrastructure. Google owns about the same amount of infrastructure as Amazon, which connects to the online giant's powerful AWS data centers via cables that cross the Atlantic, Pacific, Indian Seas, the Mediterranean, Red Sea, and the South China Sea. The IT giants try to portray these massive, ecologically damaging infrastructure projects as acts of generosity on their side. But keep in mind that they are also shareholder companies and are fully aware that the only way they can continue to grow is by bringing more people online. Wait a second, what about Starlink, you ask? Isn't our old friend Elon about to make the internet wireless any minute now? Even normally bullish Musk states that Starlink is only intended for people who do not currently have access to high-speed fiber, but who knows how that will turn out in a decade or two. For now, the future is very much undersea cables for fast-consuming vast packets of data over incredibly long distances. This summer, Google and Facebook revealed plans to construct the Apricot underwater cable together. An Apricot will connect Singapore, Japan, Guam, and the Philippines. By 2024, Taiwan and Indonesia will be included. A group led by Facebook has just funded the construction of the longest subaqueous cable in history. A 45,000-kilometer, $1 billion behemoth called the Cable to Africa that would connect 33 countries. While new wireless and satellite technologies have been developed in the intervening decades, cables continue to be the quickest, most efficient, and least expensive way to send data across the ocean. And it is still not cheap. Google refused to reveal the cost of its project in Chile, but experts estimate that subsea projects can cost up to $350 million, depending on the length of the cable. Undersea cable demand will only increase as more businesses rely on cloud computing services. With that, we've come to an end. Let us know your thoughts in the comments section below. Until next time.